this paper, and we are on question 3, and the function is defined by f of x as 2x plus 4 over 3 minus x. So write down the equation of the vertical asymptote of the graph of f. So at this stage, if the bottom is 0, then we will have an asymptote because it can't, it makes it impossible to define. So in order to make the bottom 0, so A1, to make 3 minus x equals 0, then x has to equal 3. So our asymptote is going to be at the point where if this is 3 on x, that's where our asymptote is. Right, 2. The horizontal asymptote of the graph f. Now the way you do this is if both of your x's are to the power 1, which they are, we then take the x on the top, which is 2x, and we put it over the x on the bottom, which is minus x. And then that gives us 2 over minus 1, which equals minus 2. So that's how we find our horizontal asymptote, which would be about there, say. Now, find the coordinates where the graph crosses the x-axis. So B1, the x-axis, it would be, so when x equals 0, no. So when y equals 0, over 3 minus x. So when y equals 0, then x would equal, we can't times that by that. Let's just think about this a minute. So, what do we put in to make that equal 0? So if that is, sorry. So don't worry about the top. You would do 0 equals 2x plus 4, or rather the bottom, and that would give you minus 2 times 2 plus 4. So minus 4 equals 2x, so therefore x equals minus 2. And finally, sorry about that, x, the y-axis would be, so the second part of that would be 2x plus 4 over 3 minus x, and that would mean that when x is 0, it would be plus 4 over 3, which equals 4/3. And so that's where it crosses the y-axis. Right, now sketch the graph of f on the axis below. So we know where our asymptotes are, so they're at 3 and minus 2, so let's just put those in. And minus 2, so that's there. And then we know where it crosses the x-axis. So it crosses the x-axis at minus 2. There we go. And it crosses the y-axis, that wasn't a very good minus 2. It crosses the y-axis at 4/3. So that's 1 1/3, so that's there. And so that is what that looks like. Presumably, that will do for the moment. Oh, hang on. Now, right, box 1 contains 5 red balls and 2 white balls. Okay, and box 2 contains 4 red balls and 3 white balls. Box is chosen at random. Box is chosen at random and a ball is drawn. Find the probability that the ball is red. And then let A be the event that the box 1 is chosen, and let R be the event that box Determine whether the events A and R are... Okay, so A, before we start, we would do this. So this is choosing box 1, and this is choosing box 2. And presumably, box 1, the chance of choosing that is half, and the chance of doing that is half. Find the probability the ball is red. So box 1, that's red and that's white, and it would be 5/7. So if you've chosen box 1, the chance of that is 5/7. And if you've chosen, that's 2/7, box 2, it's 4/7 and 3/7. So that would mean that the chance of you getting box so that means that our randomness would be half times 5/7 plus half times 4/7, which equals, put that in, so that's 14, so that's 9/14. Right, and the second bit, if let A be the event that box 1 is chosen. Okay. And determine whether R be the event that a red ball is drawn. Well, no, that can't be, because there's two different boxes. Okay, so if A is the event that box 1 is chosen, and R being the event that a red ball is drawn, determine whether the events A and R are independent. No, because if you choose box 1, you've got a greater chance of picking a ball, a red ball. And so the two aren't going to be independent, because if they were independent, then the chance of picking a red ball would be the same whether you chose box 1 or not.